one point and this is the second point. And we want to find the equation of line passing through these 2 points. So this is the line which is passing through this point. This point looks a little off. So let's draw it exactly over the line it would. And we know from our experience that through 2 points, a unique line can be drawn. Now, on this line, as this line extends infinitely in both directions, so anywhere on this line, we can take a third point, say P. This point is P. And let's name this point as A, and its coordinate are x1, comma, y1, and z1. All right, x1, y1, z1, the coordinate of the first point, and the coordinate of the second point, that is B. Let's write that is x2, y2, and z2. And the general point is written x, y, z, any point x, y, z. All right. To write these, to show these as vectors, we would take this origin and join all these points that will represent the position vector of point A, position vector of point B, position vector of point P. Now, they all starting from the origin and joining the given point. We can use now the triangle law to find AP and AB. Yes, triangle law of vector addition. Look, since AP and AB lie on the same line, means they are collinear vector, can we say AP is equal to lambda time AP vector is equal to lambda time AB vector. That's how we represent the collinear vector. Like AB can be, as in this figure, AB can be 3/4 of AB, lambda would be 3/4. It can be half or even any number lambda. That's why we are using it here. So AP would be lambda time AB. Now what we want to do is we want to find AP and AB and put their value here, and we got the equation of line passing through 2 given point. To find AP, let's use the triangle law of vector addition. Let's take this vector AP. This is the vector AP, and also we will take the vector AB in the bigger triangle. So in triangle OAP, look in the triangle OAP. Can we say vector OA plus vector AP should be equal to vector OP. We represent this OA by small vector A for convenience. This is easier to write. The OP can be represented by small r. This is vector. So, and OB can be represented by small b, and you put a vector notation there. So, well, this gives you small a vector plus AP is small r vector is equal to OP, that is oh no, AB is not a small r, let me correct it, plus AP vector as it is equal to OP is a small r vector. That means we can say our AP is going to be small r vector minus small a vector. Triangle law of vector addition gives us AP is equal to small r minus small a. In the same manner, we can find AB vector also, right? OA vector, let's write it here. We can say OA vector plus AB vector should give us OB vector. And OA is small a vector plus AB vector as it is small b vector. That gives you AB vector is going to be small b vector minus a vector, b minus a. Now we would put this value there, AP is equal to r lambda time AB. That means we can say our equation is will look like AP means r minus a is equal to lambda time b minus a. So that is the vector equation of a line passing through 2 points. Vector equation of a line passing through 2 points is r minus a is equal to lambda b minus a. Now this vector, if you want to change this into Cartesian, that's very easy. You simply put these values, like small r can written as small r can be written as xi plus yz plus zk. Simply substitute here. In place of small r, you write xi cap plus yj cap plus zk cap. In place of a, you want to write x1 I cap, y1 z cap, and z1 j cap and k cap, right? I mean to say this small vector a can be written as x1 I cap plus y1 j cap plus z1 k cap. Also, we can, in place of b vector, we can write vector b is equal to what? X2 I cap, okay, plus y2 j cap plus z2 k cap. Yes or no? Simply, we are substituting values of these vector a and b in this, and we want to create some space here, and we want to write this Cartesian form now. Vector form is already written, so we will write this Cartesian equation of this line. Okay, so we can write in place of r minus a. R is xi minus plus yj plus zk minus a. So these two are to be subtracted. R minus a would be x minus x1 time I. X minus x1 time I cap. All right. And then subtract these two. Y minus y1 time plus y minus y1 time j cap plus z minus z1 time k cap is going to be equal to, on the right side it was b minus a. B minus a means you will subtract a from b. So x2 minus x1 I. This should be equal to, this is equal to x2 minus x1 times I cap plus y2 minus y1 times j cap plus z2 minus z1 time k cap. And we have lambda also, because ab is equal to lambda time b minus a. So we should write lambda also with the every one of these terms, lambda times, and here also lambda time, okay, plus here is lambda. So you see, if you equate the coefficient of I, j, and k, your Cartesian form can be written now. You can find the value of lambda from all three equations, because you get x minus x1 equal to lambda time x minus x2 minus x1. That means you are actually getting x minus x1 is equal to lambda time x2 minus x1. That means lambda is equal to x minus x1 divided by x2 minus x1. And similarly, from there, you will get y minus y1 over y2 minus y1. And from the third one, you get z minus z1 over z2 minus z1. So that is the Cartesian form of the equation of line passing through 2 points.